All right, so let's take a look at some visual representations. I apologize in advance. If you're following along with me right now, your output history is not going to be this long. I had to pull another output because I forgot my histograms, but here we are. So let's take a look at our male histogram first. So we know, because we just calculated the kurtosis ratio for this, our kurtosis was gigantic. Our statistic was like 8 point something, right? So we knew that this was going to be like a lanky boy. We knew he was going to be tall and thin. So we can see that just by looking at the histogram here. This is also a really good example of outliers. We haven't seen this yet in the data that we've worked with. We have a pretty significant negative outlier here. We have a pretty large amount of white space, and we have like some mild positive outliers. So we know that this data is not really that normally distributed. It doesn't look all that great according to this histogram here. This would be an example when you see a large negative outlier like this. This would be where you could probably reject the assumption that you have no significant outliers. This you would also take a look probably at your measures of central tendency to see how that skews your data. And also, just as a heads up, this is not a crazy positive outlier here. You can see your mean is like 42 and these are like 60. So it's not insane. This would, if you had normal data otherwise and you just had these couple of moderate positive outliers, that would be a situation where you go ahead and look at your Shapiro-Wilk statistic and you look at your skewness and kurtosis. And this example, probably skewness. Well, you could look at both and see if your statistic, your calculations allow you to retain an assumption of normality. So if you just had these guys in normal data otherwise, this would not give you merit to reject everything, nor would this. You would want to take a look at what your statistics are telling you. So let's take a look at your female histogram. This is a little bit more complicated. This data actually is like almost perfectly normally distributed. It's a little negatively skewed, but if you were following along and you did your kurtosis and skewness ratio calculations on your own, you would know that your kurtosis and skewness fall within normal range for your female variables. So far this looks like it's normal, right? It looks like a normal distribution. But if you look at your Shapiro-Wilk test here, your significance is allowing you to reject your null hypothesis. So you're having to say that this data is actually not normal. And again, even if this was above 0.05, your female variable here, you couldn't do a parametric test on this data anyway because your males are so abnormal. So you would have to do a different test. But those are just examples of looking at your histograms here, and then we're going to move on to a couple different charts in the next video.